I think before we start, it will be great to have some introduction from Stefan as well. Stefan from the Faculty of Architecture. We can start slowly, so it will be nice to have a word from you.
Okay. Hey, welcome. Great to see. Great to have this series, Irina. Thank you for helping us facilitating this. The series is organized by VR Playground and initiated by the VR Lab from the Faculty of Architecture. And the idea of the series is that it replaces a networking event we were going to organize this year on the application of VR in architecture. We are also part of a field lab, and therefore part of these series are filled up with sessions from the field lab. So next week we will have a series with ongoing field lab projects, and the week thereafter we hope to have a series from the finished field lab projects. But I'm really happy to see that we have two companies involved now as well. Two companies we are collaborating with, testing software with, software for designing in VR and also for collaboration in VR. So I hope you all enjoy this first session, and we hope to see you back the coming weeks during the other sessions we are organizing. So thank you. Enjoy the series.
Yeah, thanks, Stefan. Yeah, we'll have more and more people joining, and we'll start with Johan from Arkio, and then we'll go to Gwilym from Fologram. And yeah, thanks everyone for joining. I remind you guys that I encourage you to switch on your cameras if you'd like to. And we would love to see your faces. And while the speakers are giving presentations, you can leave your questions in the chat, and then it will be easier for us to distribute the questions. Yeah, let's start. Welcome, Gwilym. Welcome, Johan. Thanks a lot for joining us. And we are looking forward to hear your stories about Arkio and Fologram.
I think to keep it a bit informal, I'm also going to try to be a bit informal, but just showing like a couple of things today. First, I want to tell a bit about myself. I'm from the Netherlands myself, so I know Stefan. We met a couple of times personally, and I'm still working and being involved with Meccano architects in Delft. So Delft is a bit of a hometown for me as well. And for 3 years now, I've been really interested in virtual reality and been prototyping and playing with creating a design application for virtual reality. 2.5 years ago, I joined an existing company from Iceland, and that's with my founder, Hilmar. And they started on something really ambitious. They wanted to make like a complete virtual, multi-collaborative virtual reality modeling environment. And the tool that I'm going to be showing today is the current state of that software. We're still in beta, so the software is still developing in a rapid pace. But we already have like a lot of good use cases of the software. There's you will see later a lot of things possible already, and we have quite a number of users as well around the world that are testing this with us. And to kind of introduce the software, it's best to actually we made a small recording with my founder to introduce the application. So I think it's best if I just play that one, and then people can see what it's all about.
Hi, and welcome to Arkio. Nowadays, most of our design work is done in 3D, but we still use 2D screens when creating these models. We now have technologies to experience our design in 3D using virtual and augmented reality. But when we want to try out something new, we have to go back to our 2D devices. With Arkio, we want to reimagine the architectural design process when not bound by 2D screens, where you can use your hands to model in 3D just like physical model making. We can create geometry, cut into it and distort it, just pick up and glue objects together, and even throw things away. We see Arkio as a 3D tracing paper, where you can rapidly prototype ideas on existing imported 3D contexts like Rhino, SketchUp, and Revit models. Arkio's modeling engine is similar to parametric BIM tools like Autodesk Revit. Using our new integration with Revit, you can easily load your latest projects to Arkio, create new volumetric suggestions or sketches that can be exported back as native Revit geometry and masses to continue documenting your design. The fun part is that this can be done from any scale and is fully collaborative, so we can invite others to join us to present or explore new ideas using your existing 3D models. Hi Omar, can you maybe make that tower a bit wider?
Sure, something like this.
Let me move it a bit more to the front. Now let's show you how Arkio works. Context is important when exploring your designs. In Arkio, you can load your site with the built-in map feature and automatically generate 3D buildings from OpenStreetMaps data. Let's move on to the plot next door and show how Arkio works. Creating shapes in Arkio is simple. To create a solid shape, I pull them up, and to create voids, I push them down into the underlying shape. Now the best part is that this is all fully collaborative.
I can even use my hands, no controllers needed. Let me just adjust the shape a little bit.
As I work, you can see how shapes snap to the edges. As I pick up shapes, they also align with other shapes, making working with Arkio even easier than physical model making.
Okay, I'll adjust the height of the building a bit. Why don't you bring in a real Revit model now, Johan?
Sure, let's go to Revit. In Revit, we can easily export a 3D scene to Arkio using our Revit plugin. This allows us to select the level of detail to reduce the amount of polygons for working with models on mobile devices like the Oculus Quest or phones and tablets. Once the model has been successfully exported, you can bring it into Arkio. We also support importing of images, program requirements, and other 3D models. Okay, let's get rid of this building and bring in the Revit model. Here you can see the model available in my library that will be placed on the table using the Revit North coordinates. Once we have imported the Revit model, we can sketch on top of it and explore some new design options.
How about trying to add an extension to the building, maybe over here?
Sure, let me work on that.
It's possible to work in any scale in Arkio. When you want to do more detailed work, you just scale down to a more comfortable size.
Why don't we add some color to the entrance? And maybe skew it a bit to make it more interesting.
Okay, let's go inside.
I think we should add a door here. Let me sketch the opening so we don't forget to add one once everything is loaded back to Revit.
Nice. So where are we now?
We're now standing in the lobby where a new restaurant will be created on the right here. Let me start by creating a wall to separate these spaces. Hilmar, maybe you can get started with the reception desk?
Sure, I'll take care of that. How about something like this? Maybe I'll also add a chair and a lamp to the table.
How about we add a logo to the wall here?
That looks good.
And maybe some chairs over here?
I think we may need to have them on the other side, otherwise they'll be in the way when people walk through the space.
Arkio elements are adjustable once created, so you can make a rough first draft and fine-tune things later. Let me cut an opening here. And maybe add a new window over here.
Okay, that looks good. So because the geometry remains editable, I can make the door opening wider to maybe allow a little bit more light to flow through.
Looks good. Let me add some glass in this window.
I think this is good. It's a winner, Johan.
I see there's a new Revit model available. Let's update all the models in the scene to their latest version. We're now outside again, where I can experience the design at human scale, while Humor is creating a new tower. I can also move things around by simply pointing at them. We can easily make copies of objects and offset them to make linear arrays. If I go back to the larger scale and give the tree a slight rotation, I can also make a rotational arrays. When using the arrays on Arkio volumes, we can make some more interesting shapes.
How about if I cut a white through the top of the tower?
That looks fun, but it might be a bit impractical. Let's get rid of that tower.
One of the main features of Arkio is that you can join a design meeting even if you don't have a VR headset, as Arkio also works on desktop PCs, phones and tablets. Here you can see how a user with an iPad can see everything that's going on inside the meeting as you sculpt the new tower a little bit. Another key feature is that you can add program tags to individual floors and immediately see total area sizes and how close you are to meeting your program requirements. You can also see these updating on the iPad as the tower is being worked on, and even edit program tags on the iPad.
On the iPad, I can easily navigate around the model and communicate design suggestions with the users inside VR using sketches. Note how the area totals change as Hilmar edits the tower in VR. Design options are another powerful feature of Arkio. Simply make a duplicate of the model, try out some other IDs, and toggle back when you want to compare them. It's even possible to create entire towers, move and rotate them around from a non-VR device. And by placing the model on a table in AR, using a phone or tablet, you can see everyone working in the scene and even sketch or model something in AR. Let's jump to human scale inside the building and check out the view. Creating spaces while experiencing them from human scale is really powerful. And these validated spatial objects can be used again once loaded back as native Revit geometry. And of course, we can play with the time of day to get a feel for how the light will flow into that new meeting space.
Why don't we add an apartment here on the top floor?
Sure, let me add some walls here. In Arkio, you can also work with parametric hollow shapes that have a fixed wall thickness. These can be used to quickly prototype out some interior spaces by adding walls and carving new window openings.
I'll just focus on the living room.
Let me erase some of these openings on both sides.
That's easy.
I can also make edits on this volume, and here you can see the constraints at work and how all the geometry is live updated to my edits. This is also possible from corners. As you can see, this is pretty powerful, and I can explore different design ideas without having to redo the modeling. We can also make sections into the building to see what's happening inside our creations. Ah, hi there, Hilmar.
Oh, hey Johan, there you are. I'm just here inside working on my kitchen. What do you think? Maybe I'll add a stove here to the counter as well.
Looking good. Here, let me help you by moving this chair. Once you're happy with your design, we can export the design options to 3D or native Autodesk Revit. Once in Revit, we can use the Arkio plugin to import that scene to generic models or mesh families that can be used as a base for facades. You can choose what materials from Arkio to import, and if you want to delete the previous import when loading new proposals. Everything created or loaded in Arkio will be converted to Revit objects aligned with the original model. The volumes in Arkio get converted to native geometry, and Arkio props like trees, people and furniture get created as native Revit families. Also, the iPad sketches get loaded and the program data and materials are contained in the geometry. Here we can see the new entrance that can directly be used as a design reference, including a reception and sketch for the missing door. Even custom imported 3D objects, like this chair, will be converted to native Revit families, so they can easily be updated or replaced by other families in your library.
One of the features that we added recently is the ability to work with meshes as well. So you can use the meshing function in Revit to quickly prototype the facades. And then you can view the results in tools like Enscape to see things more realistically. So maybe I'll just stop the presentation here and go back to the webcam. Everyone was able to see that video well?
Yeah,
Okay.
It was very nice.
So the key thing of Arkio is that we're trying to reinvent how the design process can be done. Like with traditional CAD software, you're often limited to one workstation and then one screen in 2D. And with Arkio, we want to kind of enrich that experience by having multiple devices being able to join into that same session, and everyone being able to edit and import geometry from other applications into that environment. And the main case that everyone sees is the ability to make early designs, like complete new anti-sheet plans. But one of the features that we try to highlight is the ability to also load existing models and draw on top of that. Because I think we're all familiar with that in architecture. The design process itself, like the early stage, is pretty short, but that process of refinement and how you keep developing your design over time, that's actually where most of the time is being spent. And I think that's where a tool like Arkio can really help, because tools like Revit, they have kind of a manual. They're kind of hard to use, and not everyone is able to work with tools like Dynamo or Grasshopper. There's smaller like communities of people that are good with those tools, but the majority of the users in architecture are still using tools like SketchUp or Formit and very a bit more easier modeling engines to use. And maybe talking a bit about what we support. The VR headsets that we support are like pretty much all the VR headsets out there, and like especially like to highlight this one. I don't know if everyone, maybe of you already found one or have one. The Quest 2, it's a really magical one because it doesn't like it's a really low price range for a VR device, but it also has like a lot more power than the original Quest. So this can run tools like Arkio and some other AEC related apps. And then of course the smartphones, everyone has one of those smartphones or tablets in their house or pocket. So like having an app that also works on that really helps to make the stepping stone easier for everyone in that collaboration to join in. And think a bit about the like the users that we have so far. Like we're beta testing now, so it's pretty easy for everyone to just get in. But we get some good consistent feedback from some of these companies in here, and it's really globally that we have companies using it. Also like we're getting a bit more media attention recently. We've been featured in a number of classes at Autodesk University that's running this week don't know if any of you are following all the conferences on there, but they're free to follow lots of lectures about AEC architecture related software. And we have quite a number of educational users as well, including like the TU Delft, where we're talking with Stefan. And we're really excited about that use case as well, because for students, especially in this time, it's like I think all students were familiar with working with those foam blocks and that hand modeling, and tools like Arkio really help to get that kind of interactive, fun part back into that design process. And this is a workshop that we've been doing with Cornell University. It was like 1.5 months ago, where students worked in different design groups on towards like a program goal. And in the end, we invited all the students together to the different student creations, and they toured us around in what they created. And I think I have like a small video maybe to show that, and then we can answer any questions. Let me see. We have that one in Delft. This one, because this was
88 Market Street, and
one of the students. Like,
it had some similar situation to this, although not.
So this was one of the students. They created like this project with 2 people. I think this was within 30 minutes. So it was pretty crazy that they already got the hang of an app that was completely new to them. And like one of the things they highlighted was how VR actually helped them to think in a completely different way than using like 2D screens to create things, because like I think everyone is familiar with that creative process on a keyboard and a mouse. It's not so intuitive as picking up and moving things, and being able to see things in an actual human scale. It does change your mindset and your perception on how spaces feel and work. And so here we just toured around one of that student's work, and let me just put it a bit forward. There's another project where students were pretty creative with importing geometry. So this is a Rhino model that got imported, and they used the Arkio elements and geometry to add scale to that model as almost like a physical model. They added the trees, and they added some volumes and blocks to highlight the scale qualities of certain inside spaces within that Rhino model. So it's really fun to see that students are actually using this technology to kind of work around the limitations we have now with working from home and working during this interesting and weird time, to still enrich those 3D models that they would make with traditional tools like Rhino, and bring them into these kind of environments. I can answer any questions if there's questions about the tool or about VR in general, or.
There are actually in the chat, and yeah, I see questions from Marlo, from Marta, from Menk. So it will be great if we make it a little bit more alive, and if you prefer, guys, you can switch on your mic and just ask your question out loud. Why don't we start with Marta?
Yes, hello.
Hi.
I'm wondering how it is with the workflow in terms of the complexity of the model. Can you also import more complex models, or is it mainly for use in the beginning of the design phase, kind of mass modeling?
Yeah, so the thing you saw me doing when I was creating the geometry, it's solid geometry based. And when I'm creating solid geometry on solid geometry, it's making the booleans in real time. And the distortions that we can do with the geometry that allows us to make a bit more complex shapes, but they're still limited to planes. And the arrays that I was showing, there's some magic that you can do with sub-elements and arraying that will result in some pretty funky shapes. But we always recommend people, if they really want to go with NURB style modeling, like Rhino roof shapes, to just import the Rhino model and sketch on top of that with Arkio what they want to work with.
Yes, thank you.
Thanks, Johan. And Marlo, would you like to ask a question? Or maybe Menk?
Hello.
Hey.
Thank you. Hello, Irina. It's a nice event to experience this new software. So basically, I'm also working with another software called Terraria and also SketchUp. So I saw a lot of similarities between these systems. But I'm curious about, is this system just specifically focusing on architecture, or you also want to explore some use cases in product design or service design, something? And of course, the next question is also, because you are running across different platforms, so what is the maximum polygon that can be supported in your platform? Yeah, that is two general things.
Okay. So the first question actually is a good one. We focus, and I think that's always important for a product. When you want to develop something, you have to focus first on the key user group, and we focus on architecture. And we have some people that are doing theme park design, set design, product design. We have all sorts of beta users that are interested in using it, and they're also giving us feedback. But like the at best comes to its right in working on like slightly bigger objects, because that's where we made the grid alignments and the snapping and the guides work for good for. But it doesn't like limit you from using it for other purposes. And if you want to join the beta, you're welcome to do that by going to our website. You can sign up, and then we'll just give you access to the devices that you have. The second question, like the limit of the polygons, it really depends on the device you're starting the app from. If you're starting it from a PC, that's pretty powerful. There's almost no cap, like you can go on forever, and it will at one point just get very like laggy. If you're working on a Quest device, one of these new Quests, we have like we set the maximum number of polygons for this one to 600,000 polygons. If you're working on an iPad or an iOS cell phone, we limit to 800,000 polygons. And this is because iPads and mobile devices, they don't require the high frame rates that a VR device needs. So we can put a bit bigger models in those devices than with the Quest, for example.
So I have a follow-up question. Is that okay?
Yeah.
So as you mentioned that due to the limitation of the polygon, so that what is your experience about currently you are two using in which design stage in the whole process, and how do you deal with BIM? So it's architecture data that will be used in the real project, because I think from your mockup, it looks like more like conceptual or ideation phases, and how they can go to detailed design stage with your mold.
So the key there is the Revit workflow that we built. So Arkio's engine is solid modeler, and the tools like Revit under the hood and also Archicad under the hood, they're solid modelers as well. So we have some similarities there in how we can transition that geometry into that software. And if you think about what you do in Revit, is when you move a wall, there's a shower or toilet attached, it moves with it. But basically, this same element style of modeling, this is also how Arkio works. And when we transition that model to the Revit geometry, we try to keep those BIM properties in there as well. So that's where we try to focus on now. And later stages will probably also support IFC and some other formats, but we now focus on integrating closely with Revit because that's the most popular software being used right now in the architecture field.
Well, it's very nice. So, do you have some interest to organize some like a workshop with the teams in or the student in the TU Delft and to?
Yeah.
Because I know that we also have a VR zone that they are cover a lot of architecture courses and students also for like graduation project that they use a lot in VR currently. But now I know that they are using Unreal Engine and Maya to do all the modeling and the walkthrough. But I think, well, maybe you also offer a good option for them to look at.
I would love to help. Like we help with the Cornell University. I think we're like Stefan. We're still having a conversation about when we can do a workshop like that. Is all right?
Okay.
Maybe I can add into that. Mainly, we already collaborate for a long time. We collaborate since before the VR zone was there. So the people from the VR lab moved to the VR zone, and we are still collaborating. But only we choose to continue with this part, and yeah, we foresee to do some workshops together. Absolutely, we did some workshops with the team. Hudat was part of that. But I also foresee to do some of the workshop with architecture students. Absolutely.
Okay. Yeah, thank you. If you can share this information, maybe I can also invite some design students which are interested in this field. Okay, thank you.
There is also an interesting question from Marlo. Do you think about adding mannequins into the VR maquettes?
You're talking about like the 2D like 3D people, the small.
Yeah, to my understanding, it is.
Yeah. They are actually in there. Like maybe it didn't show well in the shots. Like we have like a number of default props. We call them like little trees and some palm tree and some pine tree and some people, some cars. Like the basics are in there. But what's the most cool is that you can also import your own assets. So if you have like a certain like a 3D collection of children that you need for your school, you can just import them and place them in the model as like a little Arkio object.
Nice. And is there actually a market of VR architectural objects? If I'm looking for something really beautiful and something really outstanding, not just Sketchfab models.
I think that really depends. Like we don't have that in the software yet. Like so that's like we're kind of relying on what's available on the internet and what other 3D applications make. So if you already have a good library of for example, Rhino elements or 3ds Max elements, you could optimize those or export those as OBJ, and those can be imported as placeable Arkio objects.
Yeah, and if I'm looking for something from the side, if I'm looking for some outstanding building examples, is there any marketplace where I can find things like that?
I think the best is looking at the existing marketplaces for example, like the Google Warehouse. You have a lot of stuff here, like the Sketchfab, there's Unreal, Unity, like there's a lot of 2D stuff out there. Architecture-wise, I think this really depends on what software people are working with. Like if they're using Rhino a lot, they probably have Rhino libraries and components.
Okay. And last question from me, in case if I want to combine the architectural meeting with the client or with the student together with a negotiation, and for that, for talking, I think that platforms like Engage are quite good. Are there kind of integrations between Arkio and Engage, so I don't need to switch off from another platform to go to other platform in order to combine these two things?
Currently, we don't have integrations like that, but we're welcome to hear any feedback. So, because the tools that we have in Arkio right now, they are mostly focused on creating and editing and sketching on top of your geometry. And there might be some tools that you're referring to that are in the platform that you want to use that are pretty easy for us to add in Arkio ourselves.
Yeah.
And like building an integration, a close integration with other softwares is a bit more hard software-wise than seeing if you can implement the feature yourself.
Right. Yeah, that makes sense. And also, I think that's going to be the last question. The question from Krishna about would you then be compatible with Rhino inside Revit?
So as long as things can go into Revit, they go into Arkio because we have like a bidirectional link to Revit already. If you're working with Rhino alone without Revit, you can export to an OBJ and bring that into Revit, or bring that into Arkio. If you were thinking of also having the same workflow for Rhino somewhere next year, that we have like the kind of bidirectional link like we have now with Revit.
Okay, fantastic. Yeah, thanks so much, Johan. I'm sure there will be more questions from people, and for that case, you can leave your email in the chat. So if you'd like to, or any kind of any of your contacts. Yeah, let's go to Guillem from Fologram.
Cool, thanks, Irina.
Yeah.
And great presentation, Johan. That was really, really interesting to see the progress in Arkio since I saw it.
Going fast.
Yeah, so fast. All right, let me try to share my screen. Because I'm not going to talk very much about Fologram as a software platform and more talk about the use cases for Fologram and how we're trying to bring about change within the way we currently build buildings, specifically looking at using mixed reality tools to kind of extend the spectrum of possibility within the sort of design and construction industry. So at the moment, we're seeing a pretty clear trend towards automation and industrialized construction within our industry. And the idea is that by owning and standardizing and automating like the whole production chain, companies like Katera can achieve quite precise, cheap, repeatable, and very rapid production of buildings. Like that's the goal that a lot of companies are trying to achieve at the moment. And in this future of standardized and industrialized construction, I think we're likely to see the role of the architect increasingly be that of a specifier, of somebody who selects finishes and modules from a kit of available parts, like these parts that you see literally hanging on the racks behind these automated robotic construction teams. Now, our goal at Fologram is to develop quite a polemical approach to this industrialized construction that instead tries to leverage the efficiencies of digital tools and processes to maximize human design agency. And we have started calling this mass bespoke construction rather than mass customization or mass production. We're trying to work with mixed reality, as I mentioned before, to broaden rather than narrow the spectrum of possible designs and to try to increase the limits of what and how we build. Now, the idea of using mixed reality to build things is definitely not new. And the term augmented reality was first used by two engineers at Boeing in the early 90s to describe a system that literally helped with building aircraft wings. So ever since this technology's kind of conception as a tool, let's say, it's been intended to help people make stuff. These Boeing engineers back in the 90s, they had to prototype this kind of concept themselves using a whole lot of very low-tech hardware. They had to build their own software applications. And what we're seeing now in 2020 is that consumer mixed reality hardware has just become kind of something that you can buy off the shelf. So we work almost exclusively with the HoloLens and the HoloLens 2. These are self-contained PCs, basically, like Johan mentioned with the Oculus Quest. It's like a high performance mobile chipset that sits on the back of your head. They have inside-out tracking, so they can display digital content within the physical space that you're in reasonably precisely. And you can operate them hands-free. So they're really designed for use cases where you are using your hands to do something else, not operate a mouse and keyboard, but maybe pick things up and assemble them into structures, or hold a welder, or point at things on site, like natural user interfaces. What we've done at Fologram is really tried to take this idea of the HoloLens and mixed reality being for frontline work and for making things to heart. So we've spent a couple of years developing both software tools that I will mention very, very briefly, and also using those software tools to try to experiment with new ways of making. So working with the HoloLens allows us to think quite differently about precision in design, quite specifically. So working from very simple holographic design models, like this one that I'm going to show you here. Oh, sorry, I'm not going to show you that one yet. Working from very simple design models, you can build very, very complex objects. So you don't need very large drawing sets to describe complex objects. All you need is the three-dimensional design model, and you can use that as a guide while you're making things to approximately make those things. And so what that does is it takes objects that can be, let's say, actually pretty quick to digitally model, like this chair. This is something that's modeled in Rhino. It's just a bunch of polylines drawn in space. It took about 30 minutes to model, and it's not rationalized in any way at all, as in all of this geometry is intersecting, all of the parts are unique. There's no consideration of the fabrication order. They thread through one another. It's just a big sketch. And you would not be able to normally give this 3D model to a fabricator and expect them to build it, because it would be very difficult to generate conventional drawn instructions from this model without significantly changing the design. But the idea is that if you can see this design intent in mixed reality in the context that you're working in, which is this context here of this workshop, you can use your own intuition to fabricate something as close as possible to this 3D model. You don't need any drawings or templates or anything else. I apologize for my dog. I'm sure you can hear him barking upstairs. So this is what we managed to build from that model. So it's a 30-minute sketch, and then it was built using a holographic guide in under a day. And you'll notice that these two, like the physical object, it's slightly different to the digital one. And this is intentional. It's not a mistake. So the idea here is what we're trying to do is we're trying to, like, as quickly as possible, achieve as close as we possibly can to some modeled design intent. So we can think of precision as sitting on a spectrum from being, let's say, quite precise but slow to build, or very imprecise and very quick to build. And this unlocks all sorts of really incredible design opportunities. We're not working with a kind of an all or nothing precision that you typically are when you're working with, say, robotically fabricated processes where parts either fit or they don't. Instead, we have much more play, and we can leverage intuition, basically be designing while we're fabricating things, making decisions about how feasible it is to put something together on the fly. So this is kind of an exciting opportunity here. What we wanted to do with our software platform was to enable other creatives to explore similar ideas, to use mixed reality to, let's say, experiment with new ways of making things, to augment traditional craft processes, to build new design tools, to collaborate more effectively. And we wanted, a little bit like Arkio in a lot of ways, we wanted to build a very simple software platform that would enable users who maybe didn't know how to work with game engines like Unreal or Unity to still build pretty sophisticated mixed reality applications just within design software that they already use. So what this looks like is basically it's a way of streaming geometry from Rhino and Grasshopper to mixed reality devices, so mobile phones, HoloLens headsets, Oculus Quest 1 and 2, and then streaming the interactions that you make with that geometry on the device back into Rhino and Grasshopper so that they can trigger changes in your parametric models. And this enables all sorts of kind of interesting stuff, you know, interacting with kangaroo models on the fly, tracking markers right into Rhino and Grasshopper, building simple little modeling applications. It basically provides you with a toolkit to do most of the things that you might do in a more powerful game engine like Unity or Unreal, but just using Rhino and Grasshopper instead. Primarily what we're trying to do with that toolkit ourselves is to extend, as I mentioned earlier, how and what we build. And we've done this in two ways. One is by partnering with basically with tradespeople and with contractors in industry who are really building buildings out on site right now, and trying to introduce them to mixed reality to understand how it could change and affect how they work. So industry partners are one way where we're trying to explore this. And then the other way is with academic partnerships. So working with designers and with institutions to essentially conduct research projects where we can get funding and explore kind of opportunities for mixed reality construction that way. So I thought I'd show two examples of these. The first one is a set of projects that we've done down in Tasmania in Australia with some bricklayers down there. All Brick Tasmania is the company. And I like showing these projects because these are not technically savvy bricklayers. It's not like we're partnering with a company here that have already been working extensively with BIM models or with VR or with parametric design or with automation or anything like that. This is a typical bricklaying setup. They're really skilled craftspeople, but they haven't really seen too much technological change in their industry. They're laying bricks in pretty much the same way they've been laying them for the last 30, 40 years. Now, when we showed them the HoloLens, we thought that there was a good chance that they would pick up the technology and use it for three reasons. One is because when you're able to interact with digital models without needing to learn a new user interface, you're much more likely to get people at least give the technology a go. So one of the things we found with the bricklayers is when you put the HoloLens on them and you say, look, there's a button, if you want to push it, you reach out and push it. So long as that actually works, the brickies can figure out how that user interface works on their own. You don't really need to explain it to them. You keep it simple and they'll engage with it. They feel like experts in the software very quickly, basically. The other thing we found with mixed reality that afforded a lot of uptake from industry is that you can create shared experiences. So you have several people in the same mixed reality experience at once, and that helps you to teach one another about that experience. So you can explain when something is working or when it isn't working. You can develop efficient ways of working together from the same mixed reality information, like building things in parallel when that might not have otherwise been possible. And the third thing which mixed reality affords for industry is this obvious one of just being able to precisely locate digital content in physical space. So the thing that industry really wants at the moment, the construction industry, is just a virtual tape measure. That's the holy grail, really. If you could get rid of the tape measure and just rely on augmented reality information for doing all kinds of setup, everybody would want to use that, I think. And eventually we'll probably get there. But for now, holographic information is precise as a tape measure if you work at a fairly small scale. So we've done a couple of projects with these bricklayers where they can reliably use a hologram to set out the location of curved brick walls, basically, without needing to use any drawings, templates, measurements, etc. And that just essentially makes otherwise really tedious jobs much, much faster, simpler, more enjoyable, and they can produce a higher quality result. So how we've done that, very, very simple application that we made in Rhino and Grasshopper. So you have the design model of a brick wall that's going to be built. You have two buttons, which are made in Grasshopper, essentially the interactive geometry, which change the course of bricks, which is displayed on the headset. And that's it. Wherever you see a brick, you place it. Wherever you see a virtual brick, you place a physical brick. That's the only information you need to construct quite complex objects. We did a lot of tests with like fake bricks, with foam bricks. They're very lightweight, you can glue them together, but it proves the concept. So this is several thousand foam bricks that we built in about 3 hours, I think, in a workshop with a couple of participants in Germany. And you get a sense of how precise this process can be. You know, this object or this design really relies on very, very subtle differences in the location of each one of these bricks. And if there's any significant error here, it would really stand out. And so I think it's a good sort of proof of concept. And after doing this, we were confident enough to have a go at full scale, similar design. And Colin's going to talk about this in a second, so you'll hear him and his experience of the project.
There isn't a single brick on there that lines up to anything. Every brick is different. This would take you like 2 weeks.
Yeah.
Fine guy, and a lot of that would have to be, you know, made up. Do you know what I mean? You're not going to get it exactly like this would be.
So basically how Colin's constructing this wall, which as he mentioned, 2 weeks down to 1 week, is just using this simple interface showing the each course of bricks. And he could use that to train apprentices on the job. Anyone could participate in this project, not just the most skilled guys.
So that's all the bricks, right? Yep. So see how you are here. That one's good. Yep. This one here shows it's got to come round. So just treat that like you do your string line all the way around. So hit that back.
And the brickies also, because we were working with them, like we were on site while they were building this, they invented their own techniques for working with the hologram. So things like working in parallel from either end of the wall. They developed techniques where one guy would go through and place the bricks very approximately near where you saw a hologram, and then Colin would come through and adjust them and make fine, sort of precise adjustments like you're seeing now. And that's how they managed to strip the construction time down. And in a second, you hear Colin talk about, well, why he thinks this is going to impact.
I once seen a program on John Lennon, you know, and he reckons every song that he made, he used to think, he used to get scared that fuck.
A bit of a swear word.
Because I'll never make anything better than that, you know. That's how I'm thinking, fuck, it's time to stop. I'm nervous that I can't make nothing better.
So Colin was nervous about that being the best project he could do in his bricklaying career. But after completing that one, they were so confident that using mixed reality for kind of complex brickwork was actually going to be feasible that they commissioned us to help them do a much larger scale project, part of the Hobart Hospital. In this case, it was sort of several of these curved benches made from cut bricks, so many unique parts that made up these kind of curving components. And it shows, I think, or demonstrates about the limitation of the scale that you can currently work at from a just out of the box placed hologram when you follow best practice for trying to keep that hologram precisely aligned to site. So these things are about 20 meters long. Hundreds of bricks placed on site, and you can see this is sort of what those things look like in the middle of construction. The precision, everybody also always asks about the precision. We did some laser scanning of one of the prototypes that was built. The precision, this is around 7 mil on average accuracy, and for these brick benches, that happened to be acceptable. In some cases, 7 mil is going to be too much or too imprecise on construction sites. But in a lot of use cases, that's enough. So because of that, Colin and Ben Ulbrich, they're just excited about the technology. They want to keep using it on projects. And the main reason that they're excited about it is because it extends what they can do. It doesn't replace them, automate them with machines. Like, they enjoy their craft, and what they want to be able to do is to do better at their craft. So to take on more complex jobs, to produce higher quality results, to bring in new, apprentices, younger people, the next generation into that trade. And they're excited because like this idea of mixed reality construction is helping them do that. So the other thing that I mentioned I wanted to talk about is on the sort of, let's say, research and more speculative side of construction. So not looking at the way that buildings are built now, but trying to imagine how mixed reality construction might impact design and affect the way that some parts of buildings could be built in the future. So the Tile Inn Pavilion was a collaboration that myself and Cam Newnham designed along with Sumin Ham and Igor Pantich from the Bartlett. and with a lot of design input also from format engineers who are fantastic on this project. It's kind of a crazy project to try to engineer. And the idea behind the Steampunk Pavilion was to look at combining, let's say, a fairly traditional craft of steam bending timber with the precision of holographic guides in order to reduce the complexity of setting out formwork and molds to produce double curved parts. Like that was the hunch, like maybe we can make something out of curved timber that would look really beautiful, or we could make it far faster and cheaper and with sort of less skill than traditionally required with steam bending. One of the first things that we did when we had this idea was to do some prototypes in our studio. This is the very first one. It's 3mm timber strips set out using a holographic template. And the idea here is pretty simple. You're using the hologram mostly to set out these green elements, which are defining the shape of the curves. And then you also use the hologram to while you're bending the pieces of timber over this formwork, to just make sure that it's vaguely following the shape of the expected shape of the digital model. And because that prototype kind of worked as an idea, we just went kind of crazy with the design and submitted this for the competition. It's hundreds of pieces of steam bent timber. They're all unique. There's no underlying structure. It's a kind of self-supporting shell. And we really honestly did not expect to be successful in the competition because this just doesn't look buildable. And we hadn't ever steam bent anything from timber before besides that small prototype. And so we thought it's a very ambitious scheme, but the idea is strong. Maybe we'll come second and get published. That'd be nice. But the jury was really supportive of the project. They wanted to take a risk and asked us to have a go at building it. And so we spent about 3 months doing R&D, trying to learn how to steam bend timber with mixed reality. So the main problem with steam bending timber is that you can define a mold for a part and you can bend a part over that mold. So here we're trying to set up a mold using some adjustable scaffolding. But the timber it has some elasticity to it. So after you've steamed the piece of timber and let it dry, it'll still try to spring back a little bit into its earlier shape. It kind of has a memory. So you can see the black lines are the shape of the timber when it's on the formwork, and then the red lines are the shape of the timber when you take it off the formwork. And so it's just a inherently imprecise process, which is both a blessing and a curse. I think mixed reality lends itself very well to kind of imprecise processes, just like that chair that I showed earlier. But it means that if you want to be able to, let's say, assemble structures from multiple parts that need to fit together in a predictable way, you do still need to have some control over the geometry of the pieces you're making. They can't all just be kind of arbitrarily shaped. And so we needed to solve this problem of spring back. The first way we did that is by simplifying the formwork. So came up with a system of basically laying out these strips on a false floor using just very cheap pieces of 4x2 timber to prop or to define the curve of each one of these parts. So this gold strip here is a component from the digital model, and underneath that you might be able to just make out that there's a physical timber strip that's formed into that same shape. So we're using the HoloLens to set out the formwork, so we basically can specify the shape of a part, and then while we're steam bending, we're bending it over that formwork and making sure it actually matches our digital model. So this is a prototype that we did at Temple University in Philadelphia with Andrew Witt and Christopher McAdams, Tim Rusterholz and James Pazzi. And with the prototype, we were trying to make about a fifth of the pavilion in 2 days. And so we were working pretty much all day, all night, steam bending timber, bending hundreds of these little steel brackets. And it was an utter failure, as I guess prototypes should be. And the reason that it failed is because the joints between the small parts that we were steam bending, they just sprung back way too much. And so even though we could reasonably precisely fabricate small chunks of the pavilion, assembling those chunks together, even with a holographic guide, was just, we were fighting the material far too much, and we just couldn't make it happen. So, having all the digital tools in the world wasn't going to solve that problem. So we did another prototype, this time at Aarhus with Dagmar Reinhardt and Ryan Hughes. And the innovation at Aarhus was to try steam bending basically the entire length of each part in the design in one go. So we had 12-meter long pieces of timber that were steamed in a bag. That got rid of the springback problem. We knew we could fabricate the pavilion, so we were sort of rationalizing these parts into as long pieces as we possibly could. And this is what the bending process ended up looking like on the HoloLens. So you have the timber in a hot bag, so it's being steamed in this big long plastic tube. You have one person wearing the HoloLens who's basically guiding a team of volunteers in this almost like a dance where you're trying to form this big snaking piece of timber into the shape that you see with the HoloLens. And what's important to note here is that all the formwork is just super approximate, super cheap. It's assembled really quickly in order to produce these very complex, three-dimensional, digitally modeled curves, which very precisely come together to form the pavilion. So it's kind of nice that you can use an incredibly low-tech approach to fabricate some very, very complex digital objects. Here's another view of this kind of forming process. And so the only digital information you need, again, it's a bit like that chair that I showed earlier. I'm just going to try and pause this video for a second. The only digital information you need is just the geometry of the strip. Like in the end, we didn't even show a hologram of the formwork, and we didn't show labels for the parts, and you don't show lengths. You just have the bare minimum amount of digital information to form each one of these pieces. This is another holographic app we built, this time with a sort of an interface, a bit like with the bricklaying application, which let us step through one by one and use an analog bender to bend very, very complex steel brackets that joined the timber strips together. So you can see interacting with that interface, which is all done in Rhino and Grasshopper to show these different bends. And then you have an AR model on site as well, just to show you where these strips and brackets should actually go during construction. And that's essential just because the whole structure deforms during fabrication. These strips, even after you steam bend them, they deform a lot under their own self-weight as well. And so having a holographic guide that lets you work with flexible materials and put those, reform those flexible materials into a very precise known shape is incredibly useful. You can just eliminate the need for formwork, eliminate the need for measurements, eliminate the need for 3D scanning to check if things are right. You just have a hologram showing you the shape it should be, and then you can form it into that shape. I mean, that requires a lot of skill. Like, this pavilion's quite big, but it is possible. So I'll just sum up with a couple of videos and images of this thing. There's a couple of things which we think that this mixed reality approach to fabrication is affording us. So one is that you can work with very, very simple production chains. So this entire pavilion was made from exactly the same standardized dimensions of ash, like timber boards, and stainless steel flat bar. There was no prefabricated parts. No parts really had any cuts in them, for instance. They were just a length of straight timber, and you formed that length of straight timber into whatever curve it needed to be in the design. And so by eliminating that need for prefabricating the parts, as in, cutting them into shape with laser cutters or using drawings and templates to do that, it meant that the design could be much more adaptable. We could basically fix any mistakes that we made on the fly very, very easily, and we could work with really cheap materials and really, really minimal tools. It also meant that we could build, quite simple structures. So this is just a composite shell with the sort of steel brackets running in one direction, the timber bracing in the other direction. We didn't need to use any other structural elements in this pavilion. And then the architectural language kind of emerges from those constraints. So because you have timber boards which are twisting into a particular shape, you get all these nice moments of sort of solidity and transparency. You can really read the kind of these lines which flow from elements which are columns into elements which are walls. And you know, it's all built with extremely minimal budget and time and in this case skill. So to reiterate that first point that I made at the start of the presentation, what we're trying to do here with mixed reality is to take this fundamentally polemical position towards automation, precision, and repeatability in favor of approaches to making which really are about intuition, are about the nuance of craftsmanship, and that facilitate learning and adaptability. Like they're the things that we're super interested in at Fologram. And I think that's about my 30 minutes, so we can go to some questions. Thanks.
Thanks a lot, William. I really love how the steampunk pavilion looks like. And it's amazing that you managed to build that.
We're still quite amazed that we managed to build it. Yeah.
We do have some questions. The last one is the question from Marlo. When the wood gets wet by the rain, how does this impact the construction?
Yeah, that's a pretty good question. We did like weather treat the timber. So after it's steam bent, we used this Osmo oil to try to minimize mostly discoloration, actually, not so much deformation with the rain. And we're expecting the structure to sort of move a little bit, but it's over-engineered. So if parts of it move, it's not actually going to affect the thing isn't going to fail. So the short answer is, yeah, we expect it to move in the rain. It's still there, actually, because these pavilions are supposed to be built every 2 years, but the Biennale this time, because of COVID, has been extended out another year. So it's sitting there for a year longer in the Tallinn snow, fairly extreme weather changes. And so far it seems okay. Nobody's emailed me saying that it's fallen down. So.
And how often do you get to see it by yourself, actually?
Well, I mean, we saw it when we built it. So we were in Tallinn for a couple of months building it. And then since that was sort of a year ago now, last September, and we haven't been able to go back from Australia since because of lockdowns. But I think next time we're in Europe, we'll go up and see it.
Yeah, wow, that's a good opportunity for us to see it actually, because we are closer to Tallinn.
Yeah, it's worth, Tallinn's a pretty beautiful city. It's worth going up there.
Yeah, absolutely. There is also a great question from Hans. Hans, maybe you would like to ask it yourself.
You're muted, sorry, Hans.
Yeah.
Here we go. Thank you. Yeah. I have two mute buttons. I have one on my set and one on the screen. All right. No, from a carpentry point of view, that's not my question, but about a comment. Did you consider to glue pieces of wood together to keep them in shape? That's normally what you do when you're making, say, kind of ply technologies. Did you consider that? That was not my question, but please.
We definitely did. Yeah, we did a lot of prototyping with glue laminated pieces. The issue with glue lamination is because we wanted to work with very approximate cheap formwork, the way we were forming these large pieces, it was difficult to keep them under enough pressure to get a good bond between the laminates, and we would have had to make many smaller pieces instead. And so it ended up being much faster to steam bend the pieces than to go with glue lamination. But we actually were, steam bending was our backup plan. We spent a long time trying to make glue lam work, and we just couldn't do it. Maybe with an expert we could have. We didn't know what we were doing.
Oh, but it would require that you have like templates on both sides that you can use for pressurizing from both sides, and that is, of course, would be a very complex and would require much more AR, I believe, to construct the templates. So yeah. Anyway, my question is, how do you align your digital models with reality? There are a range of different ways that can be done, Cartesian coordinates, or like you do it manually when you're on site, or it can be machine learned objects that you identify in reality and then provide the coordinates for. Which technology did you go for?
Well, we went with the simplest one. So the way that we align digital models and physical models is using a printed QR code. So you print off the code, you fix that at a known position on site or on a workbench or wherever you're going to be working with the HoloLens. And then you're able to place the coordinate space of your Rhino model on that QR code. So 00 in your Rhino model becomes the corner of that printed QR code. And then you can move your Rhino model around until it matches with the physical environment that you need it to. That works well up to a certain scale. So once you go sort of further than 5 meters, let's say, from that QR code in any direction, the holograms start drifting, and that's when you need other tools to maintain alignment, at least if you're working with the HoloLens.
Yeah, but my department is mainly in landscape architecture, and obviously we're yet on another scale. But I was wondering if you foresee that Cartesian coordinates or real world coordinates could be applied at a point in the future.
Yeah, definitely. So Trimble have a product called Sight Vision, which is basically sub-satellite positioning, which is, I think, built to solve that problem. They give you precision down to, they're claiming a centimeter of precision with that.
Yeah, we tried that. We tried that, and it works quite fine.
Yeah, yeah.
There is also an additional question from Marlo about how did you over-engineer? Did you use FEM?
Just with conservative calculations. So the engineering was done by format, also in Rhino and Grasshopper with Karamba. So we had the exact same design model for doing all of the engineering calculations as we had for the design, and also for the fabrication in AR. It was just one Grasshopper model, which was that was actually essential because we were changing that design model all the way through construction, and we needed to make sure that the engineering always checked out. Partly because we were needing to move brackets around during construction. Some of them we just couldn't get in. So it was over-engineered in the sense that the materials were specified like just basically thicker than they had to be, and the brackets were specified more frequently than they had to be. So if any joints failed from basically the timber cracking from movement, the structure wasn't going to fall down.
Nice. And I think, that's going to be the last question from Menk. Follow-up question from the Hans question. Do you also work with mobile structures?
Mobile like moving structures, or?
Yes.
Not so much, actually. No, most things we build are pretty static. We've done some experiments with tensile structures, so they move until they're kind of fixed in place. But we've never done any work with literally moving objects, no.
Okay, and another effect besides the volume, for example, some lighting effect that mapping with using the AR with some physical object?
Do you mean doing things like light probes for the augmented reality models so that the lighting in AR matches?
Yeah.
Well, we're quite, let's say, focused on building things from mixed reality models. And when you're building from a hologram, usually it just wants to be green, and it doesn't need to be any more fancy than that. And green is good just because it contrasts with everything else in your space and isn't too bright to hurt your eyes. So we've done very little work. This might be a better question for Johan, because we generally don't use mixed reality for presentations and communication. We don't worry about how the holograms look. They look crappy, but if you can build from them, then it's fine.
I think architects, they really care for the looks.
Yeah,
and we got a lot of comments on that one.
Well, Thank you, everyone. We are a little bit late, and thanks everyone for staying up later with us. It was amazing to combine two of your presentation. Guys, thanks a lot, Johan and Gwilym. And thanks, friends, for joining this chat today. Gwilym, Johan, what will be the best way to contact you in case the community members will have more questions?
Just that email.
Yeah, email would be easiest for me as well.
Okay.
I can share my, I'll just put my email here as well.
Or you can, yeah, if you will be looking for some contacts, it's best to contact me and I'll share them.
Yeah.
Yeah, and maybe I'll give the last words to Stefan.
Yes, Irina, thank you very much. I really enjoyed this session. It's great to see the two different apps which work, well, as we tested both of them, we know how they work, and I think they have both abilities on a different level, on a different field, but they really they pick up different parts which we can use in architecture and urban design. So the part of Johan we can really use for the creative, the collaboration, and I see the Fologram we tested in architectural design, we can integrate it in Rhino, Grasshopper, and test different parametric designs. And therefore they have two different abilities, ways of working, and it can contribute to our design studios. It's great you introduced that today, and well, I'm looking forward to continuation of collaboration in developing these apps better and integrating them into the architecture and urban design education and research, of course. So that's from my side. I hope you enjoyed as well, and we will have a next session next week with BioMirror and SVP with the International School in Utrecht.
Yeah, so it's going to be the whole month of VR architecture topics, and everyone is invited to join. If you are not part of XR community, just send me an email and I'll send you a link to join all of our activities. And thanks again, everyone. Gwilym, have a good evening. Johan, have a good day.
Yeah, thanks, Irina. Thanks, Stefan, and thanks everybody for watching. We'll see you soon, I hope.
Thank you. See you, everyone. Bye-bye.
Thank you. Bye-bye.